So, there she is. We are done with new material, effectively. Okay. Today we're going to go over the spring break work. Tomorrow is drop day. And then on Thursday, we will start reviewing. So there are 10, and really it's more like 8 for the AB people, types of problems that you can encounter in the AP exam in part 2. Okay. And so we will go over each of those parts. And the way that it works is we'll kind of talk about the problem in class. We'll talk about the different parts of calculus that intersect. We'll talk about some strategies to solve those. You'll attempt and perhaps and hopefully succeed to solve a couple problems in class, and we'll go over them. And then your homework will be to solve another couple problems about that problem type. Okay? And then the next day we'll go over what we had and we'll go into the next problem. Okay? And then the time that we have left, we will be doing more of the problems like we did over break, where there's just a bunch of multiple choice, and hopefully it'll keep you reviewing and getting things going. Okay, so that's kind of how we're going to work it. BC folks, I can't do it this week, but next week we will probably spend our flex time trying to finish up the last couple of things, and then I have some problem types 8, 9, and 10 are all things specifically for you. Okay. All right. So my next problem is that I cannot find the solutions to AB review number 1. I don't know what it is. No idea. So what I'd like to start with is AB review 2, which I think was what you had to do over break. Memory serves. Right. So that was spring. Oh, you had 3. 3 and 4. Okay. I'm pretty sure I have 3 and 4. Excellent. Okay. So we'll start with number 3. I will read you the answers. Okay. In fact, I will write the answers down. So this. Okay, so this is AB review number 3. Number 1 is C. Number 2 is E. Number 3 is D. Number 4 is D. Number 5 is B. Number 6 is C. Number 7 is E. Number 8 is D. Number 9, I think, is D. Number 10 is A. And then we'll go through the 2 part 2s separately. Okay. So I'll give everybody a minute to check their multiple choice. Okay, we good? All right. So, are there questions on the multiple choice? Things that you want to go over, things that you didn't understand? Kim, number 2. So, number 2 says, in the triangle shown on the right, If theta increases at a constant rate of 3 radians per minute, at what rate is x increasing in units per minute when x equals 3 units? So I've got my right triangle here. I've got theta, I've got phi, I've got x. So I would call this a related rate problem because I know that theta is changing as a function of time and it's increasing, so that's a positive 3. But what I want to know is how x is changing. So I want to find dx dt. And the way that we tackle problems like this is that we want to find an expression, an equation that involves both theta and x. And then we take the derivative of both sides with respect to time, and we should be able to find what dx is. Okay? So, as noted, this is a right triangle. So what's an expression that I could have that would relate theta and x? Anna.
X squared plus theta squared. Or, oh, sorry, I missed it.
Okay. Anybody got one? Dagny. Okay, so sine theta is equal to x over 5. Okay. And then I take the derivative of both sides with respect to time. So that means I'm going to be using what I would call implicit differentiation. Okay. So I'm going to take the derivative of sine theta with respect to theta. And what's that going to be, the derivative of sine theta? Katie?
So theta times d theta.
Yeah, and I kind of have to take the derivative of what's inside, which is theta, and that's going to give me d theta dt. Because theta isn't a function of x, it's a function of time. Okay. And then I have to take the derivative of the other side. So Sophie, what do I get when I take the derivative of x over 5 with respect to time? Or what'd you get?
Oh,
Not x, because the derivative of x is 1, but x isn't a function of theta. Yeah, 1/5 dx dt. Okay. All right, so now comes the tricky part. Because now I want to know what dx dt is. So I can substitute some things in, like I know that the dx dt is 3, right? Okay. And go ahead.
oh, sorry. I thought you said dx.
I'm sorry, maybe I did, but d theta dt. Thank you. Keep me honest. Okay. D theta dt is equal to 3. Okay. And I want to know what dx dt is equal to when x is equal to 3. And the trick to these problems is not substituting in too early. Okay, you have to wait until the right moment, which is usually when you're trying to figure out what that rate is. Okay, so that means that this is 3, and this is a right triangle. So what's the length of the base of my triangle, Katie? 4. Which means, especially AP physics, because we talked about this morning, what is cosine theta? Anybody can answer it, but AP physics should have fresh in their minds what to do with the right triangle. What's cosine theta? It is, but it's also something else by the picture. 4/5, right?
Oh.
It was the fact that we made the picture to show that those two things were. It was a little convoluted, I'll give it to you though. Okay. So basically, I've got 4/5 times 3 is 1/5 times dx dt So what's dx dt going to be equal to? Katie? 12. All right, we good? Okay. Other multiple choice questions? Dagny. Number 3. Yes, dear.
Are you recording?
Yes, I am, because Amy's not here. And yes, because Amy's not here. Okay, so, but thank you for asking for your own self-preservation. But don't worry, we'll straighten you. Just go. So the graph of y equals f of x is shown in the figure above. If a1 and a2 are positive numbers that represent the area of the shaded regions, then in terms of a1 and a2, the integral, okay, so we want to know the integral from -4 to 4 of f of x dx minus 2 times the integral of -1 to 4 of f of x dx. We want to know what that's equal to. So the first thing we have to recognize is that integral means the area under the curve. Okay. So our first integral here goes from -4 to 4. So that's going to be all of the area that's enclosed. But remember, a1 and a2 are all positive numbers. But the area enclosed from -1 to 4 needs to be negative because it's below the curve. Okay, so this is really going to be a1, which is positive, minus a2. Because a1 and a2 are like the absolute values of what those areas are. Okay, but area that's below the curve is negative. Okay. And then I've got -2, and now I want the area from -1 to 4. And that's going to be, again, negative, so it's negative a2. Because remember, a2 is just a number, like 3. But because it's below the curve, it has to be -3. So that gives me a1 minus a2 plus a2, which gives me a1 plus a2. Okay. Good. Kim.
5.
Number 5. Number 5. Okay. Everybody got what they need for this one? Okay. Number 5. So that's the integral from 1 to 4 of dx over 16 minus x squared. All right. So you come to an integral. You must ask yourself, what's the first thing you ask yourself? Can you do it by inspection? And the answer to that question is, actually it's hell yes, but we'll come back to that in a minute, okay? What's the second thing you asked yourself? Use substitution. Where do we look for use? Under the radical, in the denominator, in parentheses, e to the something, natural log of something, okay? So you might want to think about letting u be equal to 16 minus x squared. But then du is going to be negative 2x dx. Sorry, not squared. Okay. And do we have an x? No. Okay. So that's not really going to work because I don't have the pieces. So you think inspection doesn't work. We'll talk about that in a minute. Use substitution doesn't work. What's the next thing? Integration by parts. Integration by parts, you usually need two things that are multiplied by each other. Okay? We don't really have two things that are multiplied by each other. What's the last thing? Partial fraction decomp. So you do have something in the denominator. It's actually like factorable, but you still got this radical sign. So you can't, I mean, maybe, but I've never seen a partial fraction decomp that looks like this. Okay. So if you get through all four and you're not making any headway, you're not making any progress, then chances are you messed something up. And you need to go back to the beginning, which means you need to go back to inspection. Another way of going back to, so if you have to come back to inspection, the thing you need to ask yourself is this an inverse trig function? Okay, and the answer is yes, this is an inverse trig function. Now, you can, if you want, make a decision that you're not going to memorize these. You can do that. You could probably still get a 5 on the AP exam and choose not to memorize those. Okay, because there's never really ever more than one or two of them on the exam, if that. But let's go into this saying we're going to be responsible and at least try to remember what they are. Okay. And you're kind of lucky here because this is actually a multiple choice question and they all have arc sign in them. Okay, so use every tool that is available to you. Okay, and remember the whole game about the more choices you can mark off, the better chance you have of guessing the right answer. Okay, so you got to pull out of your head that 1 over the square root of a squared minus u squared du is equal to the inverse sine of u over a plus c. Okay. So what's a going to be equal to? 4. What's u going to be equal to? X. Okay, in this case, so it's nice and easy. It's not like x is, you know, u is equal to 4x or something. Okay, which means that du is just equal to dx. So my integral here from 1 to 4 of 1 over the square root of 16 minus x squared dx is going to be equal to the inverse sine of x over 4, with the added complication that I need to evaluate this from 1 to 4. Okay. So we're going to sub in. So I've got this inverse sine of 4 over 4 minus the inverse sine of 1 over 4. Four over 4 is really just 1. Okay. And then you've got to remember what inverse sine means. What does inverse sine mean? Hannibal. Yes. So for my first term there, I want the angle whose sine is 1, and I probably want the smallest angle that'll be that. So what is the smallest angle whose sine is equal to 1? Pi over 2, because we do everything in radians in calculus. Okay. And at this point, you've already been stumped, so you've already been looking at all of the answers. And you see that they have an arc sine in them, and that you don't actually need to know what the arc sine of 1/4 is. Okay, so if you compare, you can see that the answer is B. Okay. What else on the multiple choice? Kim? 7. Ooh, 7s are tough. Okay. Number 7. The position of a particle moving along the x-axis at time t is given by x of t is equal to sine squared 4 pi t. At which of the following values of t will the particle change direction? What happens when the particle changes direction? What has to be true when the particle changes direction? Right, what has to be 0? The velocity. So I'm looking for places where the velocity is equal to 0. And then I actually want to know, like, well, I guess maybe I don't care. There's a part of me that says, well, you better make sure that it's a different value on either side, that you don't have like something weird going on. All right. So we take the derivative. V is equal to dx dt. So that's going to give me 2 sine 4 pi t times the derivative of what's inside, which is 4 pi. Oh, that's not true. I mean, it is true, but I also need to take the derivative of sine, which is cosine 4 pi t times 4 pi. Okay, we good? And then, I mean, you could play with this, you could make it look pretty, but the bottom line is you just want to know what the value is at 4 different places. Okay, so you're just going to substitute each of those in. So you put in t equals 1/8. V is going to give you 8 pi, which I really don't care about. The sine of pi over 2 times the cosine of pi over 2. And I know that the cosine of pi over 2 is 0. Right? I don't care about the rest of it. So that means that choice 1 is true. The particle will change direction. So really, we could look at that and we could already get rid of A and D. Roman numeral 2 is t is equal to a 6. So that's going to give me V is equal to 8 pi. Again, I don't care. Sine 2 pi over 3 times cosine 2 pi over 3, right? I have no idea what the sine or cosine of 60 is. That's not true. I have some idea of what the cosine of sine of 60 is, but I know that they're not equal to 0, and that's all that matters to me. Okay, so I know it's not going to be number 2. So now I have eliminated A, B, C, and D. So without even doing the rest of the problem, if you were a gambling person, you would just choose E and move on. Me, I would check it in case I switch something, but that's just, okay. So if we look at 3, where t is equal to 1, v is going to be 8 pi times the sine of 4 pi times the cosine of 4 pi. Again, I know the sine of any whole number times pi is going to be 0. And the same thing is going to hold for when it's 2, because that's going to give me sine 8 pi times cosine 8 pi. And again, that's going to be equal to 0. Okay, makes sense? Excellent. Any other multiple choice questions? 8. Okay, so number 8 is going, so we've got sine of xy is equal to x, and you want to find dy dx. So this is going to be partial fraction, implicit differentiation, right? And chain rule. So I'm going to take the derivative of both sides. So the derivative of sine is cosine xy, but then I have to take the derivative of what's inside. So I have to take the derivative of x times y, and that means I'm going to need the product rule, right? So that's going to be the first, which is x, times the derivative of the second, which is dy dx, plus the derivative of the first, the derivative of x is 1 times y, and then the derivative of x is 1. And now I need to solve it for dy dx. So the first thing I'm going to do is divide both sides by cosine xy. And then I'm going to subtract y. So I have x times dy dx is 1 over cosine xy minus y. And then I divide the whole thing through by x. So dy dx is 1 over x cosine xy minus y over x. Is that the answer I gave you? No, it's not. Because then, just to make life more complicated, they want you to have a common denominator, right? Okay, so my common denominator is x cosine xy. So for my first term, I have everything that I need. For my second term, I'm missing a cosine xy. Okay? Any other ones? Yvette, are you okay? Do you have any questions on these multiple choice? Okay. All right, we good with multiple choice? Okay, then we can move on and look at the part 2s. So we'll look at number 11. And the first thing that you need to do is to draw a slope field. Okay, so what I would recommend that you do, y values, is you make yourself a little table that looks like the grid. Okay, and so if you agree with my values here, then your picture should look like my picture. So I've got 2, 0, 2, 1, 0, 1, 0, 0, 0, negative 1, 0, negative 1. So I've got like this, 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 this. Okay. So that's part A. Everybody understand where those values come from? I'm just substituting into what dy dx is. Okay. Fiona, I can't hear you.
As you draw your
Oh, yes, I did. I will be cruel and I will say this is y equals 1. Sorry about that. This is my answer. Thank you. Okay. So part B says, while the slope field in part A is drawn for only 12 points, it is defined for every point in the xy plane. Describe all the points for which the slopes are positive. So it's going to be positive when y is greater than 1, and x is not equal to 0. Okay. And part C is to find the solution to the differential equation that goes through a specific point. So y is equal to 2 e to the x cubed over 3 plus 1. Questions on this? Dagny. Yeah. Okay. So my differential equation is dy dx is equal to x squared times y minus 1. So what I do is I get all my y's over on the same side as my dy, and I get all my x's on the same side as my dx. And then I integrate. So what's the integral on the y side going to be? Yeah, it's going to be the natural log of y minus 1, right? I could call it y minus 1 to the negative 1 if I wanted to, but when I do my inverse power rule, that gives me y minus 1 to the 0, and you know that's not right. So you have to recognize it as the natural log. Okay? How about on the other side? What's the antiderivative of x squared? Kim? X cubed over 3. Okay? Plus c. And
You always add C to the X.
I do. You don't have to. You don't have to. It's just,
So you could add it to the Y.
sure, but it'll probably make your life much more complicated. But you could do it. You will get to the same answer in the end. You could, if you wanted to, you could substitute in for your initial condition now or not. I would take both sides and raise them to the e. Remember that e and natural log are inverse operators, so they undo each other. So e to the natural log of y minus 1 is y minus 1. E to the natural log of x cubed, e to the x cubed over 3 plus c, we usually write as c times e to the x cubed over 3. Remember that when I add exponents, I'm multiplying bases, so this is really that. Okay. And then e to the c is just a constant, like c is. Okay. I can bring my 1, sorry about that. I can bring my 1 to the other side. So I've got y is c e to the x cubed over 3 plus 1. And then I can use my initial condition, which says that f of 0 is equal to 3. So that means y is equal to 3 when x is equal to 0. And e to the 0 is 1. Okay. So that tells me that c is equal to 2. And so my final answer is y 2 e to the x cubed over 3 plus 1. It's practice. It's pulling things out of the bottom of your brain where they have been ignored. And like reusing all muscles, it'll hurt a little bit, but it'll also come out. Okay. All right, we good on number 11? All right. Number 12. Part A, write the equation of the line. So that's what we get for part A. Part B, is there sufficient information to determine whether or not F has a point of inflection? And the answer is no, there's not, because you need to know if F prime changes sign on either side of x equals 0, and that is not information. You only know what F double prime is at x equals 0. Okay, C is given that g of 0 is 4, write an equation of the line tangent to the graph where x is equal to 0. So your answer for part C is y is equal to 4. And then part D is to show that that maximum of the thing is true. And then, is there a local max at x equals 0? Justify, and the answer is yes, because it's concave down. Do you want to talk about any parts of this? It was a bit of a bit. Fiona.
It is show that equation is already given.
No. It means you know what g prime of x is. So for part D, what you're supposed to do is say, okay, g prime of x is equal to e to the negative 2x times 3 f of x plus 2 f prime of x. And then it means, okay, now you take that equation, you take the derivative of both sides and find g double prime and make sure that it equals the thing that I'm telling you it's equal to. That's what show means. Okay? We good with number 12? Excellent. Algebra can be kind of a pain in the butt. All right, we can at least start number 4. Okay, I can give you the answers at least, and sometimes that is enough. All right, so AB review 4. Number 1 is D. Number 2 is E. Number 3 is B. Number 4 is B. Number 5 is A. Number 6 is C. Number 7 is D, I believe, but I think I could be convinced otherwise, because I seem to have a question mark there. E is B. 9 is E. 10 is C. Eight is,
they're up there.
yeah, they're up there.
Sorry.
It's okay. 11 part A is 0.729. B is 1.161. C is 8.33. For number 12, A is negative an eighth. B is y equals 1 over x squared minus 6x plus 13. I can probably answer one question. Kim, what do you got? Number one? All right, so number one says, let f be a twice differentiable function such that f of 1 is 2 and f of 3 is 7. Which of the following must be true for the function on the interval between 1 and 3? So, I is the average rate of change is 5 halves. So the average rate of change is pretty much just delta y over delta x. Okay, so that's going to give me 7 minus 2 over 3 minus 1, which is in fact 5 halves. So number one is true. Roman numeral 2, the average value of f is 9 halves. Recall that the average value of f is the integral of 1 over b minus a times the integral of a to b of f of x dx. Okay, so I know what a and b are, but I don't know what f of x is. So I don't know. There's no way I can actually answer that. So I'm going to say that it is therefore false for the moment. Number 3 says the average value of f prime is 5 halves. Well, that's a different story because that's still going to be 1 over b minus a, integral from a to b, f prime of x dx. But, so this is going to give me 1 over 3 minus 1, just hang for a sec, okay? What's the antiderivative of f prime of x? F of x. So this is going to be f of 3 minus f of 1, or 1/2 times 7 minus 2. So that's going to give me 5 halves. So that, in fact, is true. So I know for a fact that 1 and 3 are true. So it's not going to be A, because it's not none. It's not going to be B, because it's 1 and 3. It's not going to be C, because it's not only 3. So that leaves me with D and E. I know that D is true, but E doesn't include 1. So it has to be D. Okay, so we can spend some more time going through others of these on a different day. Have a lovely day. Please spray. You don't have to do. Goodbye, Yvette. Have a lovely night, day.